Oh, you take care. Yeah. I mean, I want to. Yeah. Yeah, I can say this. No, I didn't do that. It's like A&M is good market. Yeah, I see. Maybe. So much more is yeah. It's like I'm doing the baby decent. I'm sure, yeah, I say hopefully my second class. And I told them our paper. But okay, you're well. I just go back. That's so funny. So shady. What if some? That's what they're just. Yeah.
Okay, you can turn to page 11 in your packet. Can you tell me on page 11 and 12, which ones have we done? So today, I'd like for us just to focus mainly on disk and washer method. Those are the biggest topics of this unit. Obviously, we also need to know area, and we also need to know volume by cross sections. But these are the two big ones. So we're going to work through disk and washer method and make sure we can see the distinction between the two of them. How is it that some requires only one radius? Why is it that some require two radius? And it all depends on your shaded region. And is the flat surface of the shaded region up against the dotted line? If it is, then it's this method. If it's anything else, then it's washer method. If it's complete gap, if it's a curve up against dotted line, that's also washer method. Okay, so we're going to work through page 11 and 12, and then we'll finish off the problems that we didn't do between 15 and 16, and then we can get those types of problems under our belt pretty well, and then we'll begin our full quiz review tomorrow. We'll have plenty of time. We'll have our quiz is not until next Wednesday, so after our derivative integrals quiz tomorrow, we'll spend the second half of class just beginning our quiz review. So we'll have Wednesday, Thursday, Friday, Monday, and Tuesday. So we'll have 5 full days. Well, I may start the AP review a day next Monday, but you'll have basically a week to prepare and study for your quiz. And then the second half of class, or the last 20 minutes or so, I want us to do a practice of the quiz for tomorrow. So we'll do look over your rules for 5 minutes, and we'll take the practice quiz just to see where we stand. You know, where are the trouble spots, so that you can fix those in preparation for tomorrow's derivative integrals quiz. Okay, so let's look at page 11, part B. We have our shaded region. We have y equals 8. We have the y-axis and the line y equals 8. So go ahead and shade in. Okay, we're rotating this about the y-axis. So your dotted line will go right up against y-axis. Okay, this method or wash method. You see any gaps between the dotted line and the shaded region? Right, no gaps, right? So it's a flat surface up against dotted line. This is going to be this method. All we need is one radius. However, remember your radius and your axis revolution is always going to form a T. So we have to draw our radius horizontally because our axis is vertical. So all we need is one radius. But we also know that anytime we see a horizontal radius or horizontal base or horizontal height, we got to spend the time to rewrite our equations, right? We know that this is an indication that our problem will take a little bit longer because the equation provided for us is typically not suitable for right minus left. It's good for top minus bottom, but not quite right for right minus left. So let's spend the time to solve for x. So divide by 2, cube root both sides. Now we have something that is fit for that curve. And we know that the other boundary is x equals 0, which is also our axis of revolution. So this is this method. This is right minus left. And we can build our radius. Right minus left, right endpoint. The right endpoint of my radius is sitting on the curve. Minus the left. The left endpoint of my radius is sitting on the 0. I can drop the 0, but just wanted to show how we're getting to our radius. And then we can start putting to our volume formula. Our bounds, right? If everything that we have is in terms of y, our bounds are also in terms of y. We want to go from the lowest to the highest y value. Sometimes you have to set equations equal to each other. Other times you can just look at the graph and tell. I think this one we can just tell what's the lowest y value of the shaded region. Yeah. Okay, highest y value. 8, yeah. So go from 0 to 8. We're going to square our radius. And the rest can just go in our calculator. Right. Make sure you use x's in your calculator. And to get to cube root, you're going to do math 4. So if you want to have this stored under y1, that way you don't have to deal with as much messiness on your math 9 line. So it's up to you, but try that. Again, I'm leaving pi out of my calculator. Okay, any questions? All right, number 2, try part A. Draw your axes, see if there's any gaps. If you have a flat surface up against a dotted line, then you know it's going to be this method. All you need is 1 radius. If you have a vertical radius, you know typically that's an easier problem because the equations given to you is ready for you to use. If you have a right minus left, you need to slow down and take the time to rewrite your equations into the proper form. I found my bound by setting the 2 graphs equal to each other, and I worked it out by hand. I got x equals natural log of 5, but you could easily just use your calculator and find the intersection and get a decimal version of that right bound. That's fine as well. So we're on page 11. So if you graph the 2 equations and found the intersection, you can use 1.61 or 1.609. But I decided to just work it out by hand. That's fine as well. Notice for part A, also this method, our shader region, it has a flat surface. That flat surface is up against the dotted line. There is no gap. All we need is 1 radius, top minus bottom. Top of the radius is sitting on the 7. The bottom is sitting on the e to the x plus 2. Careful with the set of parentheses. Anything that follows a minus, we need to distribute. Once I have my big radius, and my bounds, I can start putting it into my volume formula. And I'm leaving pi out of the calculator. But it's not able to get me a fractional value, so I leave it as a decimal to 3 places, and then attach pi. Okay. All right, any questions with 2A? Try to part B. Same shader region, we're just rotating around a different line. Flat surface up against dotted line, there's no gaps, there's no holes. This method. Horizontal radius, we know we got to spend some time. These equations, this equation is not going to be a good fit for anything right minus left. So make sure you're, make sure you're spending time and actually solving for x and that you're not just swapping the x and y. That's not quite the same thing. So to solve for x, I'm going to get that e to the x by itself first. To release that x, I'm going to take the natural log of both sides to allow that exponent to come down. X comes down, natural log of e goes away. So this is now the updated equation for that curve. Our axis of revolution is at x equals 0. This method, right minus left. Radius. The right endpoint of my radius is sitting on the curve, which is now adapted to be a natural log y minus 2. Minus the left endpoint. The left endpoint of my radius is sitting on the 0. My bounds, lowest to highest y value. I think we can tell the lowest y value, or we can also plug 0 in for x and find the y-intercept. E to the 0 is 1, 1 plus 2 is 3. So from 3 to 7. You're putting y's down on paper, but in your calculator, you'll use x's. Okay, let's shift over to page 15 and 16 and try some of those problems there. So page 15, go to number 2. Page 15, bottom of the page. I drew the graph where the middle is the x-axis. Now the the x and y-axis are just there for reference. They're not going to play a role in any of the bounds. So they're just there for reference. You're just paying attention to the parabola and then the bottom line y equals -2. I see sometimes I see students try to draw bounds based off of the x and y axis, and it's just in the background. It's just there to provide reference. Does anybody still need this? All right, page 15. We have 3 minus x squared. That's the upside down parabola here. You got y equals -2. That's the one down here. Revolving about the line y equals 3. Y equals 3. That's where the top of the parabola is. Okay, we're rotating this about this line. So I'm going to rotate this way. Disk or washer method? Yes, Nick. I mean, it's definitely touching. Is that good enough for it to beat this method? It's got to be what? It's got to be a flat surface, right? And it's a curved surface, which means that there's still all these gaps available, which means we have to go through a wash method. The only place that this can support this method is if my axis is right up against that y equals -2, right? I need a flat surface if I'm going to have it being a this method. So a touching is still, if curved surface is still leaving a lot of gap here. So this is still a wash method. So from the axis, you're going to extend to the furthest boundary. That's going to be your big R. And your little r will extend from your axis to the closer boundary, which is the curve. So big radius, small radius. Make sure that you don't connect between the two curves and call that the radius. Remember, this is the center of the graph. We have to involve the axis if we want to call it the radius. Builds your radius. You know it's top minus bottom. That's an easier problem because you can use these functions. You may have to set the equations equal to each other to find those boundaries. So see if you can build from here. When I set the curve equal to the line, I got -2 equals 3 minus x squared. X squared equals +5. X equals plus or minus √5. So those are my bounds. Big radius is the 3 minus a -2. That's big R. And then 3 minus parentheses 3 minus x squared. That's going to be my little r. Okay, try part B. See if part B will give you something a little bit different here. Rotating about the line y equals -2. This one will be this method because now my dotted line is right up against the flat surface of the shaded region. All I need is one big radius. My bounds will stay the same. That's nice. Oh, and then remind yourselves that when you find from the previous problem, if you're doing washer method, that you're squaring your radius separately, that you're not subtracting the big R and little r and just squaring ones. You have to square them separately. Feels like a shortcut if you can just combine and just write the square once, but then that's something different. So make sure that you're squaring your big R apart from your little r. Okay, any questions? Okay, I'd like for you guys to take out your quiz formula sheet and study over your key for 5 minutes. And then we'll do a practice run in 5 minutes, or you can do it now. You can pick up a blank copy here. And then in 5 minutes, we'll put everything away and go through, see how much we can fill in on our own. And then we'll just see where we stand in preparation for tomorrow's quiz. But study the quiz key first. Let's do that for 5 minutes before you take your quiz. Oh, yeah. Let me, I'll make a copy for you. We'll start in 5 minutes.
I don't do just like always that that's like
All right, let's clear our desk. Go ahead and try this. All right, go ahead and start. Uh, blank copy here. If you get done before I call time, feel free to take out your key and start looking over it. There won't be a time limit tomorrow. You can take as long as you need, but